about Max 4. Now, our next speaker is Vincent Hardion from Max 4. He's going to tell us about the initial experiences with Max 4. Vincent started work 5 years ago at Max 4, when there was he was the first of third person in the control group. Before he's worked at Synchrotron Soleil for 7 years, where he gained a lot of experience, valuable experience building a new facility. His education is in software quality, which I think is probably fairly unique in this audience, and in distributed control system performance.
Okay, thank you for the introduction. So during this presentation, I will explain the status of Max 4 from the control and IT perspective. So first, Max 4 is a Synchrotron light source facility located in the south of Sweden and very close to ESS. And Max 4 is composed by one full energy LINAC that can inject in the short pulse facility, or two storage rings, one at 3 GV and another one at 1.5 GV. And we have today 14 beamlines that are funded. So at the last ICALEPCS 2 years ago, we could show that we could stack the current at 4 milliamps in the big ring. And since then, we got light. Good. So it was, we got light in the diagnostic beamlines a few days after the end of ICALEPCS. So since then, the commissioning of the 3 GV ring continued until the end of January to reach 120 milliamps and to start the operation for the commissioning of the beamlines. And in the meantime, we have installed, tested, and commissioned the 1.5 GV ring, and we got also the first X-ray end of September 2016. Both rings actually work in top-up already, and in the meantime, we had to decommission the whole MaxLab facility during 2016. Meanwhile, on the beamlines, we were quite busy to build the IDs for the beamlines, as well as to install the first in-vacuum modulator made by Hitachi for the two first 3 GV beamline. So it was in April. And 1 month later, we got the first light from IDs. And a few days after, the first monochromatic light on NanoMax. So finally, we got the first protein diffraction on the MX beamline just before the inauguration of the facility, end of June. We have also on two beamlines, the first light on the sample of NanoMax, another beamline. So if you want to know more, there is a poster session. One on the MX beamline, and in particular the nice user interface we have. We have also a poster about the continuous, so hardware continuous scan for the nanoprobe beamline that use opticography. And we have another poster about analysis software that we are doing using CUDA and Silex. So finally, we got the first user end of December. And you know how to recognize a happy user? Yes? Do you see the common thing? They all pointing their finger on the result on the screen. So that means it's a good and happy user. And we work hard, so the control and IT teams work hard to get this finger on the screen, both on the accelerator and the Beamline. So first, on the network, I mean, everything, all the control system is based on Ethernet, so we need a very good and reliable network. So, and also, we need to cope with the high throughput detector using on this MX beamline. So we had to connect the cluster, the beamlines with the cluster with a 40 gig link. We work hard also on the hardware control in order to control all the motorization of the facility with a standard motion control, ICALEPCS, and in this case, to control the ondulator with Sardana as well. So it was in collaboration with COSILAB. So it's been 5 years that we are doing Agile for the project management, and I think we'll continue because we got a very good experience of this. So we try to continuously improve the system. And in particular, we don't want to stay with old technology. We want to keep up with the version. For example, we changed CentOS to 7, Tango to 9. We are currently in progress to change Python 2.7 to 3.4, since the next version of Red Hat will only release Python 3, so it's quite important. So we are in progress. We have more or less for the accelerator 80% of the device in Python 3. And also on the Beamlines to update the Sardana control system. We did some choice, to change also the different solution, and in particular for the archiving system, we use NoSQL database. So it's HDB++. It's a system developed by Electra and ESRF. In the same times, we are trying to move the slow correction from the MATLAB middle layer to Tango to get a bit more performance. And finally, we are trying to improve the user interface and using web development. So about the web development, there will be a poster Thursday about the different web service that we provide, for example, on the alarm system, on the logging system, the monitoring, this MX-Cube free web interface, the machine status as well, different application, for example, to read the data, the experimental data, and also to have a full interface of the Beamline in the web application. As well as we have developed this user interface for the new archiving system. So there was another project that was triggered by the accelerator physicist, and the project was to be able to drive the accelerator without human intervention. So there was a steering committee organized end of last year to check the different possibility of the control system to be able to have a self-driven machine. So the constraint for the automation, it's for us on the IT group, is to understand what kind of level of automation we have to do. Because it's completely infinite. When you have one, you can work on this and to have a better automation. So we didn't know the scope. And to be able to have automation, we need, of course, a stable system and how to replace the operator in the human decision-making process. So, and in particular, there was concern about the control system, if it was robust enough. So what we did is we had an internal audit in order to categorize the control system. So we use the ISO system in order to check where is the pros and cons of the control system. I won't go into the details, but the first thing was the reliability of the system. So we had to focus, for this particular project, we had to focus on several issues. And one was that we lose the control of the power supply. It was not critical because it was not during the operation, but still, it was not very good for automation. So we had also to fix some very weird camera issue with the DHCP. And the most critical was that we lose BPM during the operation. So that was a big focus for our group to resolve this. In the meantime, there was also the performance issue of the control system. And in order to resolve this, we changed the paradigm. So before we were using a polling system. So every time a client needs an information, it requests the server, get the information. But it's not very performant, not very scalable. So we changed this thanks to the nature of Tango that is able to send events. And the last thing is, even if we are working in agile way, it's very difficult for us to provide all the interface and to understand how works the machine. So the operator, they started to write down in the wiki the process and so on, but quickly they find that if they're doing that in Python, it's faster. So they started to develop their own application, and I think this is a good collaboration. And I think it's really in our value about the user autonomy to let the people who know the development to do themselves. And one of our value is also to not try to reinvent the wheel, to integrate and to collaborate with people. And so, for example, here we got a new bunch-by-bunch system, a diagnostic system that comes with epics. So, it doesn't. We don't need to rewrite all the epics code and so on. What we did is just to bridge with Tango in order to have all our services compatible with this system. Another collaboration, successful collaboration, is the ICALEPCS. So we have more than 80% of the motorization of the facility driven with ICALEPCS. And it's not only monochromator, but it's also ondulator and so on. So it's very successful collaboration. And I want to make honor to our guest. We have two other successful collaboration. One is about the Electrometer, and we had the first operation on the Beamline, and as well as Sardana that we started to use on the nanoprobe Beamline, and we got this very nice hardware continuous scan, and they could use the ptychography analysis on top of the results. So it was a very successful collaboration. Yeah, so if you want to know more, just follow our Twitter account, and that's it. Thanks.
Thank you very much. Do we have any questions for our speaker?
Yeah.
Thank you. Your users developed Python GUI, and you said in your talk that you moved to HTML and CSS, I think, and JavaScript. So I would like to know how you...
Yeah, so it's not very easy for us to develop web application, even for us. So we won't ask the user if they know. Yes, they can. But what we have is a very nice framework called Taurus that is Qt for Tango, and they can make their own application themselves. Okay, it's not so nice than a web application, but at least it's just enough for them. And we help them to store the source code and to package everything. So it's a win-win situation.
All right, we're out of time for questions. I'd just like to thank the speaker. He's given me a new metric for measuring user satisfaction. Fingers on screen. So
yeah.
Can we thank our speaker one more time?